Hi guys, for today's session, let us discuss about Introduction to Linear Regression. This is Dr. A. Bazilla Banu, Professor and Head, Department of Artificial Intelligence and Machine Learning. Linear regression is a supervised machine learning algorithm. It tries to find out the linear relationship that describes the data, whatever you have. It assumes that there exists a linear relationship between a dependent variable and independent variable. We'll see what is a dependent variable and independent variable. The value of the dependent variable of a linear regression model is a continuous value. It means it's a real number. How do I represent the linear regression model? It is the relationship between a dependent variable and independent variable via a sloped straight line. The sloped straight line represents the linear relationship that fits the given data best. This is also called as the regression line. This line is also referred to as the best fit line. Here come the data points I have plotted between the x and y axis. What are the types of linear regression? There are two types: simple linear regression and multiple linear regression. What is simple linear regression? The dependent variable depends only on a single independent variable. So here I have a formula for constructing the linear regression. Y is equal to b0 plus b1 x. Whatever the value that I receive in y, this is a dependent variable. And here x is a independent variable. b0 and b1 are the regression coefficients. This formula is similar to the line equation we have studied, y is equal to mx plus c. So b0 and b1 are the regression coefficients. b0 is the intercept or the bias that fixes the offset to a line. b1 is the slope or weight that specifies the factor by which x has an impact on y. There are three possible cases in this formula. Case 1. What happens if b1 is less than 0? If b1 is less than 0, it indicates that variable x has a negative impact on y. If x increases, y will decrease and vice versa. Case 2. What will happen if b1 equal to 0? It indicates that variable x has no impact on y. That is, x is not having any impact on y. If x changes, there will be no change in y. Case 3. What will happen if b1 is greater than 0? It indicates that variable x has a positive impact on y. If x increases, y will increase and vice versa. If x decreases, y will also decrease. These are the three cases that we may get it while constructing the linear regression line. So, what is multiple linear regression? If multiple linear regression means the dependent variable depends on more than one independent variables. We have seen only x in the previous equation. Here for multiple linear regression, we will get x1, x2, x3 and so on up to xn. I can have n number of independent variables to construct the equation. So there are more number of independent variables to receive a single dependent variable. Such kind of regression is called as multiple linear regression. So here also always the y denotes a dependent variable. b0, b1, b2 all are regression coefficients and your slope is bj that depends upon 1 to n or the weight that specifies the factor by which xj has an impact on y. So let us see how to construct the linear regression using Python. For all the regression line, you can use the package scikit-learn. So whenever you want to construct the linear regression model in Python, you can go with a scikit-learn package, which is a free open source machine learning library. It is designed to cooperate with SciPy and NumPy libraries and simplifies data science techniques in Python with built-in support for popular classification, regression, clustering, machine learning algorithms. The project was started by David during the 2007 Google Summer of Code, and this library has grown over the last decade in both popularity and features. Scikit-learn is now the most popular machine learning library on GitHub. Libraries used with scikit-learn: NumPy, SciPy, Matplotlib, IPython, SymPy, Pandas. NumPy can be used for array operations, that is now NumPy array operations, and advanced linear algebra. SciPy can be used for scientific computations, that is optimization, linear algebra, and other essential data science functions. Matplotlib, if you want to construct visualization, you can go with Matplotlib. You can construct 2 or 3 dimension plots. IPython, if you want to increase console interactivity, you can go with IPython. SymPy, if you want to use symbolic computation and computer algebra, use the package SymPy. Pandas, if you want to do any type of data manipulation and analysis, mainly through data frames and tables, you can go with Pandas. Let us see how to install scikit-learn. If you are using Colab, you just type the line pip install scikit-learn. Run it, you will be able to see the 100% installation completion for this particular line. How to access scikit-learn? Import sklearn.datasets as datasets. Here I am just using the datasets available in scikit-learn package. So there are various steps in using the scikit-learn when I construct linear regression model. First of all, you divide the data into attributes and labels. Attributes are the independent variable. It means that X, while labels are dependent variable. It means that Y, whose values are to be predicted. So I am going to predict Y, okay, which can be referred as a dependent variable. So whatever the data set you have, if you have 2 columns, you just divide it into X and Y. Which value you want to predict, you can label it as Y, and the other values you just keep it as X. Okay, so here is the code I have given for preparing the data. So I have the student score data set where I want to calculate the score of a particular student based on the hours spent. So I am just splitting the data set such that whatever the value that I want to predict, that is, I want to predict the score of a particular student, right? So score can be considered as Y. The remaining attributes I am just keeping it as X. So X equal to dataset dot ILOC, that is location I am just using. So here if I give -1 dot value, I am just ignoring the last column. Okay, so I am just eliminating the last column, which is score. So that's why I have given as -1. The next one, Y is equal to dataset dot iLocation comma 1. There is colon comma 1 dot values. Here I am just considering all the attributes except the last column, scores. Okay, so here the index always starts with 0, right? So I have prepared the data with labels X and Y. Y is the one I want to predict, and X comes the attributes. If I want to split the data for training and testing, suppose I have 100 records, always you have to split the data 80% for training and 20% for testing. Why do I split the data? Because to ensure whether my algorithm is executing in a perfect way. So I am training the data with 80% of my records and testing the data with 20% of my records. This is done with the help of scikit-learn model selection package. I have to import train_split to perform the split. So here I am just providing 2 types of split. It is in X attribute also I have train and as well as test. In Y also I have train as well as test. So in prediction also I am just having training as well as test. Then I am using the method train underscore test underscore split. Okay, pass the attributes whatever we have created earlier in preparing the data x comma y. Keep the test size as 0.2. It means that 20% is my test size. Suppose if you consider 0.3, 30% is your test size. Here I have given random state equal to 0. So I have set the integer value. If you set random state equal to 0, always the results will be, there is every time you will consider the training and the test set the same. Otherwise, every time the accuracy may change in shuffling the records. So I have set the random state equal to 0. So here, how come I train the algorithm? There is a method known as linear regression. This is available in sklearn.linear model. So I am importing linear regression and assigning to a variable regressor. If I call the method regressor.fit, I can train the algorithm. Okay, I have to pass two attributes x underscore train, y underscore train. This is the attributes that we have already received in splitting the data. So remember, fit is the method to train the linear regression model. So you have to call with the variable regressor dot fit and you have to pass x train comma y train. Once we have trained the algorithm, we need to find the results in a line that best fit the data, right? To receive the results, you need to retrieve what is the intercept as well as slope. So to receive the intercept, you can use the line regressor dot intercept. You may get some results. Similarly, you can call regressor dot coefficient to find out the slope. Suppose if you are getting the result as 9.9, okay, what does it mean? It means that for every 1 unit of change in hours studied, the change in the score is about 9.91%. It means if a student studies 1 hour more than the previously studied for an exam, they can expect to achieve an increase of 9.91% in the score achieved by the student previously. So for every 1 hour, there exists an impact of 9.91%. So you can assume the results based on the increase in the number of hours studied. Shall we make the prediction? The prediction can be done with the help of regressor.predict. So already we call the method regressor.fit. Now you have to call the method regressor.predict. But what else you have to pass? You have to pass the test data to predict. Now I am going to assign the results to y underscore prediction. So y underscore predict is a numpy array that contains all the predicted values for the input values in the x test series. To compare the actual output values for the x test with the predicted values, you can execute the scripts. Let me show you the demo of the linear regression. So I have installed the Jupyter lab in my desktop. I have the linear regression program. I have uploaded the student score dataset. So this is my student score dataset which contains the hours as well as the scores. Hours studied by the students and the scores of the students. So you can upload any dataset by using this upload symbol and just create this plus, okay, to insert any cell below. So this is similar to the Jupyter lab whatever you are working in Chrome, but this is a desktop app. So I have constructed the lines, okay, import pandas as pd, import numpy as np, import matplotlib. So all these are basic packages that I need to execute this program. Then since I have uploaded the student score CSV file, I can call this as read CSV. Okay, so for read CSV I have to use pandas method, right? So pandas is a package which I can use it for data frames, data manipulation. So since I have created the variable pd.readCSV, just pass the data set. Since I have uploaded directly, I can give it here student_scores.csv. So here I can get the result in the data set. If I want to know how many columns and how many rows are there, I can call the method dataset.shape. So I got the result is 25,2. So I can see that there are 25 rows and 2 columns available. So the 2 columns are hours column and scores column. I can see this by executing the line dataset.head. So I'll be able to see the first 5 records present in my dataset. Then if I want to know more about the data, okay, that is the details about the data, I can get it with the help of dataset.describe. So I can see the count, okay, I can set medium, stand, mean, everything I can get it, okay, the percentage, maximum value, okay. So maximum hours 9.2, scores 95. So I can just know about the details about my data. Then if I want to plot the data, I can go with matplotlib. So dataset.plot x equal to hours, y is equal to scores. Okay. So hours studied, I am just giving it x, and scores I am printing as y, and I can put legends for my matplotlib with plot.title hours versus percentage, plot.x label hours studied, y label percentage score, plot.show. So if I execute this line, I can see the split of the whole data set in terms of visualization. Then, as we discussed earlier, which particular column I have to give for x and which particular column I have to assign it for y. As we said, if I give -1, we are just ignoring the scores because we are going to predict the scores based on the hours studied. So I have typed the line I location :-1. So I am not considering scores because scores I am going to use it for y. So for y I have mentioned as :1 because the 0th column is hours and the first column is score. So for y prediction I am just considering only the scores. Okay. So now I am going to do the split. This also we discussed, right? I have splitted the data with 20% for test size. Then for model creation, call the import linear regression, call the model linear regression. Then for training, just call the model fit, pass the attributes xtrain, ytrain. If you want to print the intercepts, slope, everything, you can use the method regressor.intercept, regressor.coefficient. As we discussed, the results shows that 9.9. So it has an impact with the hours. For every 1 hour, okay, there is an impact in the score with 9.9. Okay. So now I'm just getting the results, that is after training. Fit is the method for training, and I'm testing with the method called as predict, regressor.prediction I'm calling. So here I have to pass x test. Okay. So I will get the results in y prediction. But I should know what is the exact difference between the actual results and the predicted results. For that only I am handling the test data. So in my test data I have the actual values and I got the predicted results also. So I am just comparing whether my algorithm is working in a perfect way. Okay. So I am calling df is equal to pd.dataframe. Actual is y test contains the actual value, right? Predicted means we got the results in y underscore prediction. So I am just printing y test and y prediction. See, the actual value is 20. I got the predicted result as 16. Actual value is 27. I got the result as 33. 69, 75. Almost the results are similar. 62, 60. So here the predicted score is almost similar. So if you want to know certain metrics, okay, if you want to know what is the absolute error, what is the mean squared error, root mean squared error, these metrics can be used to measure the difference between the actual outcome and the predicted outcome. So just call the method metrics.mean absolute error, just pass y test and y prediction for comparison. Metrics.mean squared error, just pass y test and y prediction, as well as np dot square root metrics dot mean squared error, y test and y prediction. So you will be able to measure the mean absolute error, mean squared error, root mean squared error. So the less error, it shows that you have a very good algorithm as well as data set for your model. Hope you have understood the linear regression. Thank you.